Okay, here we go. This is the last flight of the XB-1, and we are just in time to hear it throttle up and go. That was a nice freeze right there. That's good.
It'll get some really great air-to-air shots again.
Yeah, and once again in XB-1, we have
Okay,
Tristan Brand.
I'm gonna flip them back over. I'm gonna flip over to the boom coverage, and we're gonna go from there.
And this will be Geppetto's 12th time flying XB-1. He's been our chief test pilot since the second flight, and he was in the seat 13 days ago when XB-1 broke the sound barrier for the first time. And it just takes incredible pilots, not only the courage to go take an airplane, a brand new airplane, and to do with it something that it's never done before.
Discovery, go
But
at
also
throttle
on
up.
today's flight, it's
Hey,
going to be a
Tago,
real
32-month
demonstration of flying
resub.
skills, as we have to hit a very specific point in the sky at a very specific time in order to capture that image.
Hey, Reese, what's going on?
All right, so you heard the call there, about 15 seconds from pushing the throttles up. Let's just watch XB-1's takeoff today.
Okay, here we go.
Alright, on myself in band.
Test control, you are in band and go for brake release.
Discovery, go at throttle up.
See the 238 there, it'll follow in what's called an interval takeoff. We expect about a 10-second delay. The T-38 will follow XB-1 off the runway, and then they'll rejoin in the air.
Did it need significant landing leg leg strength compared to a standard aircraft? I forget which landing gear they're using, Dons,
Here we
but
go.
it is off the shelf if I'm remembering correctly. Okay, here we are.
Discovery, go at throttle up.
Boy, it just never gets old to watch this. I feel
Absolutely.
like there's nothing quite so human as flying. Just gathering speed, going down the
Discovery,
runway.
go
You
at
see
throttle up.
rotation about 165.
Drives me
And
29
we're
months,
airborne.
Gunny with a 7-month resub,
About
Kick me with a 47.
195 or
Thank
so
you.
was the speed I saw.
XB-1 is in the air. There she goes.
Oh, what a beautiful sound.
That-
A beautiful view.
That never
Hey,
gets
methane.
old.
It never,
Yeah,
ever gets old.
He's good. Okay.
Just an absolutely beautiful airplane. Physics does not let you make an ugly supersonic jet, not by any stretch, and XB-1 is just a beautiful machine. So, Nick, what's going on now?
Okay, so we just saw XB-1 leave the ground, and XB-1 turned right. It's heading out to the east, and we're going to fly up east and enter the airspace above Edwards Air Force Base.
Good.
And then we're going
plane
to fly out
taxiing
about
by.
60 miles or so to the east. We'll turn west and enter again the same piece of airspace we were in on our last flight. We call it the Bell X-1 Supersonic Corridor. It's named after, of course, Chuck Yeager and his famous flight conducted in 1947, which was the first ever
Hey, Dina,
supersonic
what's going on?
flight of any
This is not
manned
a beaver.
aircraft.
Yeah, you're right.
So we're using that airspace because that is the appropriate place to do supersonic testing. And we have a special agreement with the Federal Aviation that gives us the authority to do that with our test mission here today.
Yeah, we're super proud and grateful. The FAA gave us actually the first ever authorization to break the sound barrier in a civil aircraft over land in the United States. Also grateful to the team at SpaceX and Starlink, who are providing a pretty impressive antenna that we have in the Chase T-38 airplane. That's what allows us to get these live air-to-air views.
Yeah, this one actually I think is just a zoomed-in camera from the ground, but hopefully that Starlink comes up here pretty soon, and then we'll be real close. But we talked
Something
about
like
this on
that,
our last
Basdon,
flight.
yeah.
XB-1 just out-climbs the T-38. It's a very performant aircraft, and sometimes it's hard for the T-38 to catch up. So as soon as they get a little bit closer there, we'll get some of those more dramatic shots closer in.
Yeah, no, I remember the first time I flew the XB-1 simulator on the ground, and I was climbing at about 14,000 feet per minute. I turned to the team and said, well, this can't be right? It doesn't really perform like that, but yet it actually does.
No, it does with all three engines pushed up. And again, we talked about this last time too, but we have to design for the off nominals. And so if you lose an engine on takeoff and your gear are still down, you have to be able to climb very well with only two engines in operation. So because you're designing for that condition, when everything's working nominally, you just have a tremendous amount of performance on tap.
Yeah, just absolutely incredible airplane. Well, let's talk a little bit more about today's mission. Nick, will you tell us how the Schlieren photography works?
Yeah, so we're going to fly a flight path today where XB-1 is going to be flying in a very precise position in the sky. And the reason why we're doing that is because we have a team on the ground. They're actually NASA employees, and they have a ground station set up remote in the middle of the desert. And we chose that position because of the location and where the sun will be. We're going to use the sun and use the collimated light that comes off of the sun. There's an image there on the screen. You can kind of see a description of what I'm talking about there. And NASA has special optical equipment and special cameras that they can use to capture that image. What we need to do is eclipse the sun. And by eclipse the sun, I mean we need to fly in front of the sun relative to the position of the equipment on the ground.
So what they're trying to do, guys, is get what's called a Schlieren image. Schlieren images are ways to basically image how stuff flies through the air at supersonic speeds. It's a very good way to understand how loud the plane is going to be when it's breaking the sound barrier. It's a very good way to see how supersonic air moves over the aircraft. Schlieren images are used throughout the aerospace industry. They're used for wind tunnel. They're used in wind tunnel testing. They're used for flight testing, like what you're going to see here. And they're used basically for just general analysis of aerodynamics, particularly at higher speeds. This is the last flight for the XB-1. The company Boom, oh, there's a plane going by. The company Boom Supersonic has their XB-1 test plane that is flying right now, and this is the last flight. This is the last time this thing's going to break the sound barrier before Boom works. But that's not the end. They're going to eventually work. Yeah, see, there's a picture of a Schlieren right there. That's a T-38. They're eventually going to move to passenger jets. The XB-1 is just a single-seater plane. It's just a single-seater plane, and what Boom is going to do is they're going to try to capture a small to medium, like narrow-body airliner that can break the sound barrier. Basically, they're trying to restore supersonic transport to the skies. But they're trying to do it basically not with off the shelf, but they're trying, actually, you know what, the best way to say this, and my colleague over at NSF, Ryan Caton, is actually the one that came up with this, and it's actually pretty dang smart. Boom is trying to do with supersonic transport what SpaceX was trying to do with launch vehicles with Falcon 9. They're trying to make something better that everybody would want to buy. You know what I mean? These things don't necessarily... So, like, there were two high barriers of entry with Concorde back in the day. When the best of British aerospace and French aerospace banded together to make the Concorde, there were two big things that they really quickly found. That's a live stream shot of a plane flying around. That's pretty good. There were two very, very big things that they were kind of problems that they faced, and that's a problem that basically Concorde had to deal with throughout its entire career. The big one was that it was expensive because it was using off-the-shelf military stuff. So military stuff is usually hard to maintain. The Olympus engines were very, very complicated. The second part of it is that it's loud. Sonic booms are a thing. If you're going fast enough, even where Concorde was flying at higher altitudes, still makes a boom down on the ground. Now, Boom isn't necessarily trying to solve the... they aren't necessarily trying to solve the loudness of it. NASA is working on something like that. What Boom is trying to do is solve the cost problem of supersonics. They're trying to make a lower cost thing. So basically something that's not using military hardware, something that's using more garden variety stuff. But yeah, this XB-1 test flight is supposed to get some Schlieren imagery so they better understand, you know, how this plane flies through the air. And that is going to, all this data is going to be used to build Overture, which is their, if this is their Falcon 1, Overture is their Falcon 9. So should be pretty good.
On XB-1's first supersonic flight is the ability to break the sound barrier without an audible sonic boom reaching the ground. And that's not magic. It's not even part of the airplane design, really. It's about how you fly the airplane, the altitude and the speed relative to the current atmospheric conditions. You know, many kids think back to like high school physics. You've probably seen that experiment where you get a glass of water, you drop a pencil in it, and then it looks like the pencil's broken. Well, that's because light waves bend as they go through different media that have different local speeds of light. And it turns out this is really true of any wave, and it's true of sound waves as well. So when the boom comes off the airplane, it passes through the atmosphere, and the atmosphere is not the same temperature. It's actually colder above, warmer below, and that means that the speed of sound, which is a function of temperature, also varies. So just like light waves bend, so do sound waves.
Yeah, right here,
and they bend towards colder temperatures. So they make kind of a U shape as they come off the airplane. Now, if you break the sound barrier too low of an altitude or too high a speed,
listen to what he's saying.
Those rays will then hit the ground, and that's when you hear a sonic boom. But if you do it high enough at the right speed, it actually creates a U shape in the atmosphere. The boom turns around and it goes back up before anybody could ever hear it. And that is a big deal because that's what's going to allow us to legalize supersonic flight over land in the U.S. and in the rest of the world, and then speed up not just transoceanic flights, but flights across the country as well.
I think we had a graphic that could help articulate that point. Is it possible to bring that one up on the screen? So there you go. This is just roughly explaining what's going on here, and we refer to it as a cutoff altitude. Below that, you just do not hear the sonic boom.
That's right. Yeah, and so today, so exactly how these waves propagate is a function of the current atmosphere. What are the winds? What are the exact temperature gradients? And our forecast today is that we're going to have a cutoff altitude about 7,000 feet.
Yeah, I believe that's correct, about 7,000 feet. Below that, you won't hear it. So it looks like Geppetto is now lining up for the first supersonic dash. I'd expect him to start accelerating here pretty soon. So let's listen in and watch XB-1 on its fourth supersonic dash.
Somebody asked what AB means. I actually don't know what that means in regards to this. That is, dude, this is straight up just a live stream from the chase plane, which I still can't believe. That's actually pretty cool.
On condition right there. You see the center.
Switch to manual power. We think we'll be ready by the time you spin it. If you can give me a time estimate.
Oh, afterburner. Yeah, that makes sense.
Okay, so I think what happened there is our timing was a little bit off.
11:15, yes.
Copy 11:15.
And Geppetto is, they said spin it. So what Geppetto's going to do right here is make a 360 and come around for another attempt. Now we have pre-calculated exact position timing for the even numbered minutes on the 10s. So 11 a.m. was our planned first supersonic target. Followed by 11:10, 11:20, 11:30, etc. As many as we have fuel for, frankly. We're going to do this pass as many times as we have fuel for. We believe we'll have enough fuel to do at least 2 or 3 attempts. But if we're not precisely on that time, we've pre-thought about this, and we have charts where we can manually recalculate a new altitude to do it at, and recalculate a new timing and a new spacing. So we can do this at any time. We have just kind of pre-planned the even number of minutes, but we can recalculate a new attempt dynamically on the fly. And this is something we've actually practiced. We have flown this rehearssul twice in the T-38. The first time we did that, it was a full dress rehearsal.
Mojave.
And
that's where they are.
NASA was on the ground, and we were actually able to achieve 2 out of 3. Geppetto flew it the first time, and he missed it. He was a little bit high. He took that feedback, adjusted the technique a little bit, and again, this is all hand flown by Geppetto. And so he was able to hit the second one, and then again repeatedly on the third one. He practiced this flight again on Friday, just to shake the rust off a little bit. And if I know Geppetto, he's looking to sink every shot that he takes. So he likes a challenge, and now he's got to go off the card, so to speak. So we're not flying the precise GPS location that's written on the cards, but we're calculating a new one, and he's gonna go for that dynamically.
Yeah, again, it just
Can you
really
believe
speaks to the skill of the pilots, but it also speaks to the skill of the team that designs and supports the flight. Nick, we implemented some features in the avionics to support this just in the last 2 weeks. Can you tell us a little bit more about that?
Yeah, that's right. So we basically use this the same code block that we use for our ILS landing needles, the same kind of things that airline pilots use to land an airplane at any airport in the world under ILS conditions. And we repurpose those needles, those guidance needles, to give Geppetto the information that he needs to fly precisely on time, on target. And this is something that one of our software engineers on the team, Jason Reichenecker, he just went to town with it, collected all the data from NASA, and wrote a custom application similar to that ILS needle system that basically gives Geppetto the cueing that he needs to fly so precisely. All of these points are flown off a GPS altitude and not a pressure altitude. That's because
I don't think he's high enough up in the air for that, but maybe.
What the atmosphere is doing on any given day. So he's looking at GPS altitude and then the guidance provided by that custom boom written code that's on the primary flight display right in front of him.
Yeah, and again, it speaks to the power of having control over that whole airplane ourselves. You know, most of the airplane is designed in-house by Boom, built either directly ourselves or with our own people directly supervising the suppliers that are building those components. And this has led to some of the many lessons learned out of the XB-1 program.
I don't see why not, Archie.
The importance of so here we go. We are. It looks like the afterburners are lit. And we are accelerating, and so all right, it's time to get excited.
Here we go. 0.9. This is where it paused last time. That's expected because of the error in the air data system. Once we get deep into the supersonic regime, we should see. Yeah, there we go.
There we go. And XB-1 is supersonic now for the 4th time.
Mach 0.16.
Now, what speed are we expecting Geppetto to accelerate to today, Nick?
Okay, so we're targeting a true Mach number of 1.14 on this dash. Now, we learned on our first supersonic mission that the air data system does have a little bit of error in it. You know, any pressure transducer, any piece of instrumentation will have a little bit of error in it. And so we're compensating for that. And we're going to fly a little bit faster because of that error. So you might see an indicated Mach number of 1.14 to 1.19 or so, and we're dynamically adjusting that so that we're at 1.14 true.
Beautiful. And then that is a new top speed for XB-1 right there, right now, and on today's flight.
Just heard a 30 seconds call.
Slow down, recover.
Uh-oh.
We've gone a little fast there, but we're still.
10 seconds.
Oh,
5, 4, 3, 2, 1.
Mark. Okay, so there you have it. That was the first
Schlieren
pass.
Recover. We do not have TM.
Okay, lost some TM.
Chase, they need you to recover. They drop out.
Throttles are out of burner. I'm recovering.
Copy that.
Whoa, that kind of
so let's explain what just happened. You see the data that froze on the bottom of the screen. We've just lost our telemetry link with XB-1, so I'm sure the avionics team is diving into that right now and just looking for a fix. But we did get one Schlieren pass on that. Geppetto will probably circle, and we've also
there we go, it's back.
Schlieren shots 10 minutes apart to deal with contingencies.
Damn,
also, the team on the ground, their camera systems, they record a very high frame rate and they make these massive data files. It takes them about 5 or 6 minutes just to offload them and reset the equipment for the next pass. So we're planning on doing Schlieren attempts on center 10 minutes.
This is killer, man. This is really cool.
The numbers are changing now, so it looks like they've fixed whatever telemetry bug crept in there on that run.
Yeah. Now this is something that we were working
the telemetry picked up 1.18. You see that? That's like true supersonic. That's getting out of the transonic regime. That's like fully breaking the sound barrier.
There are roughly 10,000 wire terminations on the airplane, and many megabits of data coming off in real time, and that comes off the radio and antenna, digital antenna on the bottom of the airplane. We've got dishes that track it, line of sight. And then that feeds the control room, and a couple dozen flight test engineers are watching their stations and able to watch everything on the airplane.
Dude, they're just
now,
north of
Edwards.
Edwards.
On the first supersonic flight, for those of you who tuned in, you might have heard a knock it off call. And Nick, can you tell us what's that all about? Is that people just having fun, or?
Yeah, it's kind of a funny term, knock it off. It's like, what is somebody like just goofing around in the control room or something like that? It's actually an industry standard term. And what knock it off means is it's just something that's very clear when you hear it over the radio. There might be some static or something kind of interfering with the communications. But knock it off just means stop the test point, because we're seeing something that we didn't really necessarily expect. And so specifically in that case where we heard a knock it off call on our last Supersonic run, we had been operating in Afterburner for longer than we had ever been operating
Tag
with
me, Knight.
Afterburner
I can't
before.
go. I'm trying to watch this, dude. I can't go looking for it
doing so
around
at a
on
higher rate
Discord.
than we had ever
If
seen.
you want me to see
And
something in the
an
Discord,
engineer
guys,
saw that and
just give me
diligently
a
called
tag,
knock it
please.
off. We slowed down. We checked the values, and we realized that everything stayed within limits. There was no exceedance or anything like that. It was a precautionary measure, so we don't expect that to be a problem. But you might hear knock it off if any engineer sees any of the thousands of parameters that are being beamed down look unique or new or something like we haven't seen before.
Yeah, and that's actually, it goes to very much to one of the things we've built here on XB-1. It's not just the airplane itself, but it's a safety culture, and that's a culture in which everybody is encouraged, and not just encouraged, but actually expected to speak up. The team starts their day every day with a daily stand-up, and the first agenda item in the daily stand-up is, were there any safety or quality issues from the day before? So in a certain sense, every member of the team has access to the e-stop button, and if they see anything that they don't feel as meeting criteria for safe flight, they're absolutely encouraged to speak up, raise their hands, and say, hey, let's deal with this, and then move on.
Yeah, we do it every single morning as part of our daily brief, and then we also do it in the control room when we're flying missions live. It's we call it the no vote. Everybody has a no vote when they see something that we need to slow down and take a look at.
Yeah, it's absolutely fundamental to building a safe airplane. And we know we're in the business here at Boom of taking what we've done on XB-1, scaling it up to create an airliner that any of us can fly on. And so nailing not just the technology, but the safety culture and that reliability is super important. So it looks like as we speak now, Geppetto is kind of coming around, getting set up for another Schlieren pass. And while we're doing that, why don't we talk a little bit more about that boomless cruise and what it really means for our future Overture passengers.
What Wartos said,
when we started the company, we were very focused on enabling supersonic flights on the transoceanic routes, the ones that are today the longest flights, the New Yorks to Londons, the LAs to Sydneys, that tend to be mostly over water.
It is
the
article,
boom out
yeah, I
over
checked
open
it this
ocean,
morning.
where there is just nobody there to hear it. Therefore, it can't be objectionable. But we always knew we would want to bring supersonic flight to all passengers on all routes and provide
Why not fly something remote like this in this day and age? Pilots plan to be on the real one. Why? Pilots are going to be on the Overture, so why would you test like that? Protecting, if they're going to have, if their final design is going to be piloted, it would probably be a good idea that the test design is piloted too. That's the reason. Why remote? I don't know. I don't know, test as you fly, dude.
Sonic performance than other commercially derived engines, which means we can punch through the sound barrier at a higher altitude and keep that sonic boom from reaching the ground.
Well, that's just because they're a point design for supersonics, and they're not a derivative of a subsonic engine.
That's right, yeah. I mean, so the team building Overture basically has an in-house engine company that can build us exactly the engine that the airplane wants to have, and that is a huge deal for the airplane, a huge deal for us to be able to optimize every bit of that performance. Additionally, computing power is a big deal here. Is because the speeds and altitudes required for boomless crews vary from day to day. Being able to have real-time weather data and real-time sonic boom forecasts are enabling us to go reliably fly supersonic while being confident that there's never going to be an audible sonic boom in the ground.
So what you're saying there is that we have this graphic that kind of explained the concept, but that's something that we're going to embed in Overture, and that'll be a real-time calculation that can be done at any time. And you've even discussed, you talked about like maybe an autopilot feature where we could leverage that.
Dude,
yeah, I think the autopilot on Overture will have sort of a boomless mode, and when that's engaged, the autopilot will automatically fly the right speed to ensure that no boom is heard on the ground. And if it turns out there's a more optimal altitude that will allow even faster speeds, it'll cue the pilot to request a different altitude of air traffic control.
And so looking for confirmation of that boomless flight, we've talked about why we're flying exactly where we are, and that's to enable the Schlieren imagery.
Yeah, and she's turning to break the sound barrier.
But in addition to that, we have two data collection centers basically on the ground right now. One of them is approximately 10 miles in front of XB-1 supersonic path. The other is about 20 miles in front of XB-1 supersonic path. And they're basically some sophisticated microphones. And we're sitting there waiting for confirmation that no boom was received, basically. If we record absolutely nothing, that'll be a win there. But we strategically placed those on the ground looking for confirmation of the Mach cutoff and that it was a boomless supersonic cruise. We got word actually from one of those two teams that on our first supersonic pass, there was in fact no boom heard on the ground.
There we go. Well, that makes 4 times we've broken the sound barrier with no audible boom. And all of that data, again, just goes back, fed into the algorithms and machines that will allow us to just do this reliably day in and day out. You know, supersonic flight today on XB-1, it's incredibly exciting, but, you know, we're not done until we've made supersonic flight boring and routine.
That's right.
So it looks like we're getting ready for our second supersonic pass here, getting set up again for another take at getting that Schlieren image.
Yeah,
for the ADSB.
It's interesting, you know, one unique dynamic of flying around in this airspace where there's so much military testing that happens on. It's a very busy radio frequency environment. You got lots of different teams doing different things with telemetry. There's GPS denied environments that are that we have to kind of navigate around to do our testing. So we're very thankful for using this airspace, but it's challenging to do so and maintain.
Keep the camera on that. Keep the camera on that. Yeah. Awesome! Oh, that plane's a looker, man.
He is pointed back west again, and he is inbound for the initial fix on what looks to be the next supersonic Schlieren pass. So maybe about a minute or two out from that at this time.
Yep. So when we're getting ready to go supersonic, what we'll see. There we go. All 3 afterburners are now on, and we should expect to see the Mach meter start ticking up here.
Awesome. Okay, here we go. Speed is increasing.
Yeah, you know, so supersonic flight is exciting.
What's up, WD?
You know, one question people ask me a lot is what is it like on board the airplane when the airplane breaks the speed of sound? Nick, what is it like?
I hear it's transparent. There's really no sensation to the people in the airplane when it goes supersonic, like this moment right here that Geppetto is just about to experience.
Yep, they should click over any moment now.
There we go.
There we go. Once again, XB-1 is supersonic.
5th time.
5th time.
Yeah, baby.
Seems like it works.
Discovery. Go at throttle up.
Yeah.
Hey, Swifty, what's up, man?
Concorde famously had a big readout in the cabin because nobody could tell, but it was pretty cool to know that you're going supersonic. But you can't tell from being inside the airplane.
Yeah, you know, we will do that on Overture too. We'll make sure you have a big display on the speed and that moment of breaking the sound barrier is celebrated. But it really is. You have to go make a big deal out of it because otherwise nobody would notice. It's completely transparent.
Okay, so Geppetto has decelerated again. I see the engines are at about 80% or now. And after that dash, we're turning to the right. It looks like Geppetto might be circling to regroup for position.
Yeah.
I'm also quite sure we might have lost telemetry on that one again. So unfortunate, but these are the things that come up when you're flight testing an aircraft. Is sometimes telemetry doesn't play very well.
Yeah. Look, see how he's turning around right here? Guys, that pass wasn't as
back to the right. We'll see.
Pass wasn't as long as the first one. Here. I'm not necessarily sure if that's a good or a bad thing, but we'll see.
So, Blake, why does supersonic matter to this is a test airplane on a test mission, but why do supersonics?
You guys want to see something kind of interesting that I'm noticing with the ADSB? If you guys see me look up here, this is the ADSB transponder here. So, look at the T-38 that's flying. See that? See the T-38? You can see its path, right? Now, these boys are saying that they're having some problems with telemetry. Look at the XB-1's telemetry. Look at its ADSB. I wonder if that's a thing. Uh-oh. Right? I mean, it does clearly not a big deal. Plane's still flying around, but could just be the antenna location. It's using MLOT, not ADSB. Care to let the class know what that means?
a.m. New York time, and you can land
I don't know
in
what
San
that means.
Francisco around 10 a.m. San Francisco time, and get your whole day started. So it's just that power of time savings gives us back, that irreplaceable thing. We just can't get more time back. Speed is what gives us that, and it also just unlocks new possibilities.
Blake, I've done some of those flights. I've been to
indicated Mach number 36025 altitude.
Okay, so you just heard a real-time correction.
MLAT is
or
lower
calculating
resolution
for
ground-based
time
radar.
For a next Schlieren pass, that's what
Okay.
that comm from Erin, who's leading the control room team.
No, they're moving to a bigger thing, Viper.
Erin Young, she's actually, I think she's been at the company longer.
What I've been telling people is that this is the last flight of the XB-1. It's the last flight of the XB-1 in a very similar way that Falcon, like when Falcon 1 was flying for SpaceX, they stopped flying it and they moved to Falcon 9. Boom is going to stop flying the XB-1 and move to their kind of breadwinner, so to speak, Overture. So this is the last flight because they basically got all the data that they wanted to get out of this project, and now they're going to move to making a bigger plane. Not that much bigger than the XB-1, to be 100% honest, but this is a single-seater aircraft right here. It's basically like a civilian fighter jet, which is kind of nuts to me.
This is space. I'm in space.
But Overture, the thing that they're trying to make, look at the thing bank. The thing that they're trying to make is a passenger plane. So they're moving on to bigger and better things after this, basically, is what I'm trying to tell you.
But he's been here a good while too. Jeff joined in 2019, and then you can kind of see Erin standing up right now in that image, and right in between him, Warren Koenig. He is our chief engineer on the program, and he's actually helping the back row on this mission and facilitating the communications.
Yeah,
between the
X-Wing,
team
that's a
on the
good
ground,
point.
at NASA on the ground and the control room there.
This is space. I'm
Hey,
in space.
Viper,
No, the
gifted
team
10
is really
subs.
the
Thank
most
you.
important
Decent
thing
gifted a
here.
sub to Supersonic.
First off,
Boo!
you would not be able to do this without just an incredibly talented team. XB-1 was done by about 50 people, including the designers, the engineers, the technicians that assembled the airplane, the pilots, the flew it, the management. So I think that's the smallest team that has ever built a supersonic jet.
For sure.
Yeah, and it has given us the only team on the planet, the only team that has designed, built, and flight tested a civil supersonic jet. Of course, there's some teams that have done this in the military world, but that's very different, where you're not constrained by budget.
And just recency. I mean,
They're
last
aiming for
supersonic
something that's
flight
kind
of
of...
any new clean sheet airplane.
So, can't see me. From what I understand, Overture is basically going to be like a regional jet size, if I'm understanding this correctly. So, I'm thinking like a CRJ-800 or like an Embraer 190 or maybe even 737 sized. Like, they're not trying to build Concorde. They're not trying to build a gigantic supersonic plane. Because Concorde very much demonstrated that it's not... The supersonic transport is a very specialized thing, and it has a very certain type of market. So based off of that market research, they're basing the size. They're basing the size of what they want to do based off of that. It's like you don't need a gigantic plane like Concorde. That's one of the ways that they're trying to keep costs down, as far as I can tell. You're not trying to build a 200-person. You're not trying to build like a 200-person supersonic transport. 60 to 80 passengers. Yeah, it's not very big.
We did not want to give ourselves a get out of jail free. We wanted to build the safety technology and the safety culture that would make Overture possible. All right, well, it looks like that Mach number is creeping back up again.
Accelerating 3 afterburners. Here we go. There we go. The 6th time XB-1 is supersonic again. And on this mission, we're a little bit higher, but just because of the later time in the day, we're compensating for the sun changing position. A little bit higher, and we're going a little bit faster.
Southern California,
synonymous.
1.15. Get it back in 30 seconds, I can accelerate again.
Where we're fighting through some telemetry issues, and so that's what you're hearing there in the comms, is the data has frozen. That just means that the radio link between the ground and the air is unfortunately just not behaving very well today.
Yeah, and so when we don't have the telemetry data, we tend to back off on test conditions a little bit, again, because the entire point there is that we've got a couple dozen engineers able to watch their displays in real time, monitor thousands of parameters, and make sure that everything on the airplane is performing exactly as we expect it to.
That's right. You know, one of the things that we did on our first supersonic flight.
Approaching. I'm 10 seconds out. Subsonic. No need for a shot here. We are done for the day.
Copy that.
Oh.
So fuel state, we had a
We're
pre.
still in the dark as you're heading back.
Yeah, we had a level. Basically, we call it bingo, and that's when we have exhausted the fuel for our planned testing for the given day. And so we're at that point right now.
I don't know,
where we can
Evil
come
Rays.
back,
It's hard to
and
say.
There's still some test points we can do on the way home, but we don't have the fuel anymore to do another Schlieren pass.
Great. Well, that makes now 6 times that XB-1 has.
Next up is card 3 recovery. We still don't have SAs to the aircraft. Anything you're seeing off nominal would be appreciated.
Uh-oh. I heard off nominal.
Okay, so we're nominal. From the control room, that's what Aaron just communicated to Geppetto's.
You sure about
just
that?
Not seeing the live data that we need.
You sure about
testing
that?
up at 35,000 feet. But that you heard that call there that everything is nominal, so no issue
I
with the
did-
airplane.
that's not
just
what I
unfortunately
heard.
Not getting the data in the control room that we hoped.
Right. So this is really a bittersweet day for me, and I think for the entire XB-1 team, because this is the last time that she'll fly.
I echo that sentiment wholeheartedly, Blake, is that this is so big.
The off-nominal call was nominal. Oh, yeah.
For 8.5 years. And what Geppetto's doing now is he's bringing it back. He's going to execute the last landing checklist, extend the landing gear for the last time. And
Also,
bring it home for
SUV
landing.
driving by.
Very bittersweet because this has been the highlight of my professional career to work on XB-1. But I'm also equally excited about everything that we have in the future for us.
26,330 in the box.
There you go. Can you talk a little bit about what's coming up for us in the future?
Yeah, well, I mean, while it's incredibly sad for me to leave the exciting world of flight testing and experimental aircraft, it means we get to go all in starting tomorrow on what we started the company to do, which is to build that Overture airliner. And so as we speak, we're literally about a week away from calling design freeze on Overture. We'll be calling design freeze on our Symphony engines in March, and our goal is to be making thrust on those engines around the end of this year. Start building the first Overture
that's so cool.
in about 18 months. Rolled off the line in about 3 years, put it in the air in less than 4, and our goal is to be ready for passengers by the end of 2029. So while it is exciting to watch flight test, and I know many of you outside the company have been following along as well, cheering us on, and that's been exciting for all of us. We're all going to make the Overture and Symphony development as transparent as we possibly can, show you pictures of things as they're getting built, tell you about what's going on. And I just want to really say thank you to everybody who has made this possible.
Pretty good, man.
Most importantly, the team
good.
here at Boom, who has committed themselves
Dude, look at that.
and pushed
That's
through
awesome.
so
Dude, that
many
plane is
difficult
nice. That plane's
problems that
cool
others
looking.
said were impossible or never even tried. The investors that backed us, but also all of our fans out there who have constantly cheered us on and said they're looking for us to win, and that helps us get up every day and keep doing what we came here to do.
Yeah. Thanks for saying all that, Blake. And really, we have achieved here with this flight test program what
I'm
everyone
happy we
thought
did.
previously was impossible, and that a startup
Evil,
cannot
right?
do
Dude,
a
that plane's
supersonic
a
airplane by
looker.
themselves
It's
without
a
the help of
pretty
the
looking
government,
plane.
without the help of the larger OEM organizations.
I don't
And
know
what
how
we
I
have
feel about
done
the
now
3
6
engines,
times
but
is show the world
it
that
does
we
look
can
cool.
Design, develop, test safely a supersonic airplane.
Uh-oh,
So
don't film
6
that.
passes, we've broken the
Don't
sound barrier
film
6
that.
times at
Turn
this
the
point.
camera.
We'll
Don't
see,
film
how
that.
the quality of the Schlieren images come out. I
Uh-oh.
hope we get something good there. But I did get confirmation from the
We got a number
team
for
on
you
the
to
ground
call.
that all 3 of the passes that we've done today also produced no sonic booms.
Wow, that's pretty big news. I'd like to say that
I'm
Boom
kidding,
heard around
guys.
the
That
world,
was
but it's actually
that
the
was
Boom heard not at
Edwards
all.
Air Force
Boom
Base.
heard by nobody, I think, which is in this case really good.
So Mojave's over
Indeed,
here.
Indeed. Personally,
It
that's
should
part
be
of me that
coming
kinda
into the
wanted to
picture
hear
in the
a
top
sonic
right of
boom.
your
But
screen.
actually, speaking of sonic booms, I think it's kind of
Something that's super interesting. Look, if you see right there, there's a huge oval track out there, like a NASCAR track almost, so to speak, out in the middle of nowhere. It's actually not a NASCAR track. That's where automotive manufacturers do testing. They have all their test tracks out in the middle of the desert. It's out there around Mojave, which is actually super cool. Okay, Joe, there you go. Patrolling the Mojave almost makes you wish for a nuclear winter. Actually, if the test track is there, that means Mojave's over there. It's to the south. It's not to the north.
Mythbusters a few years ago, where they tested the myth, can you break a window with a sonic boom? And it turns out
Are
you
those
actually
solar
can. You have to
panels?
fly supersonic at an
Maybe?
extremely low altitude, which of course produces a very loud boom. The boom in some ways
That's
is
in
like the wake
Pueblo,
of a boat. So
Colorado,
the bigger the
Tessa.
boat,
That's
the
probably
bigger the
about
wake.
1,000
And also the
miles that
closer
way.
you are to the boat, the stronger the wake is. But flying up at high altitude,
No problem,
we
Dan.
can put XB-1
Dude, look at this.
Overture,
Look at this.
boomless cruise, where literally you
Oh,
don't
that's
hear it.
sick.
But up
It's
at
being-
30,000
Dude,
or
they got a
60,000
Starlink
feet,
taped
where
to the
Overture's gonna be
roof
flying
of this
supersonic.
T-38.
It's a completely different phenomenon.
I'm not even kidding.
And,
it's
you
not
know,
That's the
taped,
difference
but
between
still
what we
cool.
call boomless and quiet boom, right? Those are two different things.
That's right. I mean, really, so
Ooh.
XB-1
Hey,
will
baby.
make no sonic boom at all flying subsonic.
How you
Supersonic,
doing?
when it's in the boomless cruise
What the
condition
heck?
at
This
speeds
is
up to
sick.
about Mach 1.3, it will make no audible sonic boom. And when we accelerate past that, it'll make a sonic boom,
So-
but at a pretty high altitude.
What Geppetto's going to do here, he should be turning right on final here momentarily. Looks like the active runway at Mojave is 3-3, I think that runway is. Oh, no, 30. So he'll be turning right here in a moment.
On future aircraft beyond XB-1 and Overture 1.
And there's really no reason why we couldn't design for a quiet boom. It's just there's no agreed upon standard. So what we can do right now that is easy to do without any certification requirements is to cruise around
Really
in
is,
that
can't see
no boom regime. How much faster is that than, like, let's say, a typical airliner would fly?
Oh, it's up to 50% faster. And so to put that in concrete terms, it means coast-to-coast flights are 90 minutes faster. That makes a real difference. And those hybrid routes where we're flying partially over water, partially over land, they're going to get even more speed up because those overland components can be flown boomless cruise 50% faster than today's airplanes.
I mean, like I went on my honeymoon with my wife to
There's
New
the test
Zealand,
track.
and those flights are just so painful. I'm the biggest aviation geek you probably ever met. Man,
This
we
would
could
be
fly
their
forever,
Falcon
but,
9. This is their Falcon 1.
who
Overture is
isn't
their
on a
Falcon
commercial
9,
flight?
so to
and
speak.
if the stewardesses came out, halfway through the flight and said, "Who wants the flight to be done?" or "Who wants to continue on for the second half?" I think everybody in every airplane would raise their hand and say, "I'd rather be on the ground now."
What?
So that's what we're trying to do here.
Yeah, I mean,
Should
that's
be getting a right
I
turn
don't know
here
a single
momentarily.
person who doesn't want supersonic flights, so long as they're safe, affordable, sustainable, and quiet to the people on the airplane and quiet to the people on the ground. And that's what we've really demonstrated here with XB-1. We've built a supersonic jet with airliner technology. It scales up and it solves the big problems. It solves the big problems that Concorde
You're
had.
down.
It solves the sonic boom problem
Dude.
with cruise. It solves the efficiency
that's
problem.
killer,
It solves the
That's so
takeoff and
cool.
landing noise problem with turbofan engines.
Dampers off for now.
And what that means here is,
There's the runway. There's runway 30.
Sorry, I just get distracted by the landing gear coming down again because, again, I'm a landing gear engineer and I just geek out on it every single time I see it. And
Bro, that's awesome.
Control your go damper.
Dampers coming back on.
Yeah. So we snuck in a test point there. Talk about it real briefly. We did.
Those are
some
wind
more
turbines
dampers
out
off
there,
investigation
just in
here.
case
Even
anybody's
in the last
wondering.
5 minutes of XB-1's
Dampers
flight
are
test
on.
campaign,
Planning checks complete.
we just did more stability augmentation off assessment of how the airplane flies, and that's going to be very valuable data.
It needs-
as we scale
it
that
needs
up
high
and apply it to
landing
the
gear,
flight laws
dudes.
on Overture.
You need long legs, long landing legs here, so to speak. Long landing gear. The reason why is because when you're designing to make something go fast, having a lot of wing makes it kind of difficult, right? Because obviously, like if it's more bullet shaped, right, with no wings, it's going to go the fastest. But you still need some wing to keep you up in the air. So that wing design right there, this kind of strake delta. I'm not exactly sure what the real name of it is. I call it a strake delta wing. That wing allows you to basically fly like a bullet up there and fly like a plane down here. But in order for that wing to work, to generate a lot of lift down here, right, the plane has to land at a high angle of attack, which is why you need that long landing gear. Watch, he's going to really bring that nose up of this plane coming into land. Oh, dude, there's a junkyard right there. Any good pickings?
and of course, as you can see in the landing here, XB-1 comes in at a
3 engines, yep.
Pretty high angle of attack, right?
pretty high angle of attack, right?
Yeah, see,
And
he's
that's
got to
why
bring
we
he's
need
got to
that,
bring the nose up for those
augmented
wings to
reality
generate
computer vision
lift.
System.
Oh, bring it down in the hash.
There we
Okay.
go, another beautiful
Oh, we
touchdown.
greased it. Geppetto has made this look easy every single time he's done it.
Yeah, planes like that are not easy to land.
It's been a pleasure working with you and the team.
That's awesome. Yeah, landing at 180 knots,
And there
right,
goes-
Tim? You see
There
that?
goes Wiper.
You need that. You
He's
need
having a little bit of fun.
You have
Awesome.
to
So you heard the
you have to land at a high angle of attack like that, dudes. With that type of wing design. But that type of wing design is what's really good for going fast up there. That's really important. Also, Mojave is an aircraft graveyard, in case anybody's wondering. That's what all these planes are.
Geppetto needs to land the airplane, and that's of course so we don't have to have
I
that
don't
big,
think
heavy
so,
dropping
Jason.
nose like Concorde famously did, just to provide visibility. But we need this an
there you
experimental system, and we need a safe way to test it for the first time. So we've demonstrated this technique that I'm unaware of anyone ever doing.
Actually, it's
in
about
manned
the
flight
same.
test.
No, but the
Other
shuttle was a
than the
little
Navy,
faster
they do
than
it
this, believe it or
routinely
not.
landing on aircraft carriers. But we applied that to prove the system out, and I would expect Overture to do something very similar during
Rolling
the
out to
initial
the end of the
portion
runway.
its campaign, and then once that system's been proven, we'll just land it on the cameras every time.
Yeah, Jonathan, don't remind
So
me of those.
XB-1's going to slowly roll to the end of the runway. It'll turn left, and then it'll taxi back and shut down right behind us here at the desk. And this really, that'll be, that will conclude XB-1's flight test program. But we have collected so much data about how a supersonic airplane
T-38
of our
should be
own
coming in to
design
land here
performs in the
momentarily.
air. So we're just going to get that data, use it to validate our tools, our design tools, our
Like I
test
said, dude, look at that
prediction,
plane. That plane is
modeling, and that's just going to inform
plane's a
everything that we
looker.
do looking out. So this was a battle very well fought to accomplish 13 safe
Geppetto turning
test
on to
flights, 2 of them
taxiway
being
A,
supersonic,
or
6
Alpha
times
right there.
breaking the
See,
sound
that's what
barrier.
that indicator.
This is data that no other team.
That's what that. If anybody cares what all these things say, so he's on taxiway Alpha right now, right? And that sign said that is the cross for taxiway Foxtrot right there. He's crossing A and F right there. That's what that sign said. So check this out here. That sign is crossing a runway. See, runway 4-22. So runway 4 or 22. This is taxiway A, crossing a runway threshold. He's already passed it on the ADS-B, but see this dotted line right there? That's called a hold short. Hold short means that's basically entering the runway. See, there's one over there and there's one over here. He crossed the threshold for runway 4 or 22. Have you made this in Kerbal? No, I haven't. No. Keep going down taxiway A. The T-38 actually is going to come into shot right behind him. Watch right here. If I'm looking at this right, T-38's on taxiway hotel. It should be right there. You should be able to see its landing gear. And they move the camera. So once again, there's the indicator for taxiway A. He should be crossing another hold short here in a moment. You should see another yellow and striped dotted line here. Yep, there it is. That's the hold short for the next runway, for runway 8 or 26 on taxiway Alpha. There we go. See, I told you the T-38 was behind him. See, those are the hold shorts. You don't cross these unless you have permission from the tower. But if you look at the sign, A8-26. So this is where taxiway Alpha crosses runway 8 or runway 26. That's what that sign means. And that is the hold short. You don't go past this unless the tower says you can go past that. Turning on to taxiway Charlie, there's the tower. There's the tower. This is a road. That's just a regular road. It's an indicator for the planes. And so Geppetto should turn this thing onto the ramp here. Back to Boom's hangar. Ooh, plane. What kind of plane we got there? Almost look like a Cessna 410 or something. What else is down there? What other plane? Hey, it's right behind him. It's right behind me, isn't it? Oh, dude, this stream is sick, dude. Is that cool? That's awesome. Come on.
Well, there we are. The engines are going to be shutting down on XB-1 for the final time, and that marks the close of one chapter at Boom and for aviation. But it also marks the opening of a new chapter.
Wait a minute. Oh, square body 4 detected. Oh, square body 4 detected back there. Okay, cool. Sorry, I had to point it out.
The
I'm sorry.
chapter that we all get to be even more excited about, because next time next time there's a supersonic test flight, it's going to be on the airplane that you and I and everybody watching is going to be able to buy a ticket.
Would you just look
fly
at
on.
it? Oh,
That
would
is
you
gonna be
look
incredibly
at
exciting.
this?
But also the real moment that I'm looking forward to.
Dude.
Nobody wants to be
That's
reminded
awesome.
of supersonic flight. Just the same way that nobody wants to be reminded of subsonic flight today, when it is just the normal way for all of us to fly.
I can't wait for that time, Blake. And, you know, our broadcast will be concluding here shortly. But, Blake, thanks so much for joining me on the live stream this time. It's been awesome.
Likewise, Nick.
That's the
It's been a
CEO of the
pleasure working
company,
with
by
you
the way,
over
guys.
the last 8+ years, and I'm looking forward to your next chapter, to Boom's next chapter, and to bringing supersonic flight back for just about anybody.
And thanks, everyone, for watching, joining us here today from Mojave. This will conclude our broadcast, but 2025 is going to be a really exciting year for Boom Supersonic. Keep following the channel.
There's the T-38 over there. Hey, a Saber. Is that a Saber liner back there? All right. That's an antique. See that thing? Oh, dude, come on. No. Just keep the cameras rolling. Just keep the cameras rolling. Just keep the cameras rolling. I just want to see this. How long until the next plane is ready to fly? They're looking at having a deliverable product by 2029, Paul, but that means the plane will probably be flying a little bit before that. Where's that square body? There's an OBS Ford sitting out there somewhere. Ooh, Dodge van over there. It's, sorry, as somebody from where things rust, it's still weird to me seeing like old vehicles out there that are in like mint condition, like including planes, because stuff lasts a long time in the desert. It doesn't rust because there's no water. Oh, there you go, Pat. There you go. Commercial supersonic jet is an amazing thing to see. Yeah, and no salt either. That's right. Dude. That was awesome. Dude, Boom's like setting a gold standard here for like test flight coverage with a live stream. So there were dudes in the T-38. Let's see if we can see it. In the passenger seat, or the second seat on that T-38, they have a Starlink on a mount that's affixed to the cockpit. And they were live streaming this. They were live streaming the chase plane, which is so freaking cool, dude. That's awesome. That's so neat. Where does the air go? That's right, it goes in this square hole. Now build it in KSP, yeah. Actually, I should probably mute that. I don't know if that music is legit. It's kind of a shame that that's the last time that's gonna fly, but hey, onward to bigger and better things. Dudes, look at it from this angle. It looks, see how it bears a passing resemblance to Concorde? That's not a coincidence. Look at it. Would you just look at it? See? Kind of, okay, you start to see it now. It's got the same wings. They're just smaller. Oh, come back. Where's that dang old Ferd over there? Hey, back it up, back it up. Space shuttle, very, yeah, similar to the shuttle. Yeah, see it over there? Look at that thing. That thing's mint. I want it. I want it. Give it to me. See it? F-250 right there. Long box. Single cab, long box. Just like mine. Concorde looks good because math says it needs to. Yeah, that's a good point. There's also a van over there, an old van. Damn, that plane's a looker. Small TriStar, yeah. Yeah, right. Bring back real pickup trucks. Dude, this shot. The test plane just flies in the back of their main shot. That whoever thought this was a good idea that's pretty smart. That's pretty cool. They did that on one stream too. Yep. Dude, I think I saw a Saberliner over there. See it? See that? See that over there? Hold up. Not this guy. Is that a Saberliner? November 603 AW. Alpha Whiskey. November 6. No, it's John Cena. Dun, da, da, da. Dun, da, da, da. What are they going to do with XB-1 now? I'd probably take it apart. I'd take it apart and figure out to look at it, right? I need me a square body for it. Yeah, absolutely. Rockwell International. North American Rock, dude. It's Saberliner. I'd hope maybe they'll donate it to the Smithsonian or something. That would be pretty cool. Back it up, back it up, back it up, back it up. That's awesome, man. Very cool. Very, very, dude, that's so legit. Jack was with the group by the tower. If he had worn his orange shirt, we could have spotted him. Yeah, mini trucks are always a good time to work on. But mini planes are even cooler. All right, guys. Well, that was the last flight of the XB-1. They did go supersonic, and that's it. That kind of sucks, but anyway, looks like a really nice day out in Mojave, and yeah, that plane looks. See, now I'm wondering what that plane was. I'm wondering if it was a freaking Saberliner. Supersonic without making a sound. Yeah, but not for the same reasons as like the quiet supersonic boom. This plane can go. There's a point where you're going. If you're going supersonic between like 1.2 and 1.4 Mach, that basically the supersonic boom doesn't. The sonic boom does not have enough energy to get to the ground, and it actually reverbs back up into space. Boom had an article. They posted a huge thread on X about this, and I'm gonna go see it. I'm gonna go check it out in a little bit. We'll probably do that for Space News. But yeah, they basically, that's very interesting, because I don't, guys, I'm not necessarily sure that that's something that people didn't know, right? I'm pretty sure they knew, like, that was a thing, but, you know, like, it's kind of interesting to me, because that means they could make a plane that could cruise at Mach 1.4 over land, and you'd never hear a sonic boom. Mach 1.4 is pretty fast, considering like the fastest planes that fly, fastest commercial airliners, I should say, that fly right now don't really go much faster than like 0.8, 0.9 Mach, somewhere in there. I mean, 1.3, 1.4 is a big deal. Like that's not Concorde fast, but it's that is a significant, that is a significant, that's significantly shorter than like a full subsonic flight. Hey Bradley, 54-month resub. Convert the Starline. That aircraft is a Saberliner, Rockwell NA-265-65. Yeah, dude, it is the Saberliner. What an antique that is, Hunster. I've been looking it up while I'm explaining it. It's that dang old plane over there. Where is it? It's the plane that's parked to the right of their hangar, or to the left from this shot. Yes, your ears still hurt. Oh, nice, Joe. Great shots. Yeah, there it is. Dude, see that thing right there? So the reason why I called that thing out right there is because the Saberliner is, not a lot of people know this, the Saberliner, so 603 AW right there. The Saberliner is an F-86 Sabre in passenger jet form. I don't know how many people know that. I don't know if anybody cares. I'm not trying to take away from the XB-1. That's an F-86 with a passenger. It's basically an F-86 passenger plane. Not a lot of people know that. Yeah, that's why I was like, what? What is that? Why is it there? Also, it looks like there's a MiG behind it. It looks like there's a MiG behind it, like a MiG-21 or a Sukhoi behind it. That's definitely a MiG. The tractor landing gear is a dead giveaway. Yeah, the Saberliner's super cool, actually. Really, really, really cool jet. It's an F-86 with more seats. You're focused on the T-38. Oh, of course, everybody can appreciate T-38s. I think T-38s have really funky looking noses. I don't like the nose. Everything else about the plane, it looks right to me. Is Rook there? I don't know if Rook's there, no. New York to London would be 3 hours and 30 minutes. Currently 7 hours. Yeah, XJ, there you go. Saberliner has the same engines as a WB-57. There you go. There was an old Rockwell T-39 Saberliner at your A&P school in Montana. Yeah, dude. Yeah, like I said, Rockwell is just like, well, we make a jet plane that goes fast. Why not just add more seats? That's, dude, freaking Saberliner. Here, look at it. Would you just look at it? It's got the same wings as an F-86. It's the same thing, which is super freaking cool. See? The more you look at it, you're like, oh yeah, it is. Yeah, baby. Sick. Wait, is that the plane from the picture? That's November 211, Bravo Romeo. That's 265. That's NA-26560. The other one, the one that's there is a 65, so it's a newer plane than this one. Yeah, man. Freaking Saberliners, dude. Yeah, it's got an F-86 wing in it. And that thing is about as maneuverable as one, which is super cool. That's super cool that we just saw that thing chilling back there. And there's definitely, like I said, there's definitely a MiG behind it. That's a MiG-21, I'm pretty sure. The tail is a dead giveaway, and the tractor landing gear. Hold on, let me check something. I'm going to Google Earth. I'm going to do it. I'm doing it. I'm going to Google Earth. What's that line going from the tail to the front? Crayola, that's how they did antennas back in the day. Yeah, that wire is an antenna. Yeah, we were tracking it on ADSB the whole time, you know, so it was super cool. All right, where are we? Where are we? Here we go. All right. Well, Javi's over here. XB-1's hangar is right by... Yep, absolutely a MiG. There it is. It's still parked in the same place that this picture was taken on October 7th. There's your MiG. The Saberliner isn't there, though. Excuse me. Saber... Oh, no, it's right there. Well, there it is. Well, there it is. Ooh. Hello. What are you doing there? Hey, baby. How you doing? Oh, just got some RB211 action right there. That's pretty neat. There's their T-38. That's Boom's T-38 right there. It's parked in the same spot. Are there two of them? That looks like a Lockheed TriStar right there. Look at the back. It's definitely an S-Duct. That's a TriStar. Cool plane. It looks like they might have two of them. But yeah, see, look at the Saberliner from the top and it looks like an F-86. Yeah, Aqualex, yeah, I got you. Is that Stargazer, Rochelle? Is that Stargazer? If it is, that's the dude, that is the last airworthy TriStar in existence. Is the square body still parked there? Holy crap, it is, Paul. It absolutely is. It's right there. The square body's there. You can tell because it has a super long pickup bed. It's still there. That's awesome. Can we get close? Oh, please. Please. Oh, yes. Oh, that's awesome. Oh, that makes my day right there, dude. Yes. Is that actually Stargazer? Well, we're here. Hold up. We should be able to figure that out real quick. Yep, that's Stargazer. Absolutely Stargazer. Oh, what a cool plane, man. Mr. Yak is out here somewhere. I should have gone with him. Should have gone with him. Oh well, missed it by that much. Wait a minute, hold up. Can we see the MiG? Oh, the MiG isn't there in this picture. There's a stupid helicopter there. Blasts. What else can we snoop around on here? Hold up. Wait, what? Really? Well, there's 211BR. That's the 265-60. There it is. It's right there. Okay, we found it. We found the other Saberliner. Anything else cool? Just a very, very unhappy C-130 over there. 707. What's that doing there? This is great. I could do this all day, dudes. What's the importance of Stargazer? Trenton, it's a first stage. Oh yeah, first stage. It launches rockets into space, dude. Yeah, Stargazer. It's an L-1011. So it is the last airworthy trijet. Lockheed trijet, I should say. Here, let me show you a picture of it. Yeah, here we go. So that thing launches the Pegasus XL, right? there. See? .707 could be Travolta's. It's the wrong color and it's missing a lot of parts. Shh, it's grazing on the grass in its retirement. Yep. Aero guesser. They make a big deal of 737 max range compared to what's advertised. Interesting. Wasn't it retired? Nope. Stargazer is still doing its thing. Yeah. Yeah, Zach. That's why that thing is cool, because it launches stuff into space. It doesn't have the ATK logo on it. How I knew that thing was Stargazer is because that's what it looks like now. It has Northrop Grumman's logo on it. So it's a blue logo with a blue stripe, right? So if we go and look at that street view again, see? You can barely see it, but blue logo, blue stripe. That's absolutely the same plane, which is super cool. Is OATK still in business? No. Well, yes, technically. Orbital ATK was bought by Northrop Grumman a little while back. Yeah. It was Orbital Sciences, and then Orbital Sciences merged with Alliant Tech Systems, and then they both got bought by Northrop Grumman, so now it's just Northrop Grumman. Yak got a good view of the Stargazer, Stargazer, yeah, super cool. Mojave, man, that's a cool place. There's, like I said, there's also an aircraft boneyard out there that has, there's a couple of queens out there, which really, really hurts to see those planes like that, but, you know, especially considering that these look like 747-400s, which are really, really nice planes. But, yeah, that's the end. This is the end. I'd love to turn them into a home. Yeah. Yeah. Yeah, Hell Hydra, you're not wrong. Whoa, what are those things doing there? Those are antiques. Those look like C-123s. I think they're C-123s. Hold on. No, it's not a C-123. I always forget the name of this damn thing. I'm incorrect. That's not right. What the heck is the name of that thing? It's not a 141. Is it a 133? Yes, that is exactly what it is. Yeah, it's a 133. See, it's got that weird hump. Are those Excuse me? Excuse me, what the heck? What are Drakens doing there? That's weird. There's a lot of interesting stuff out here. What else we got? Anything cool? What's that doing there? Oof. That, I don't know if I like that. That's, okay. Yeah, those are some TriStars out there. 747. Oh, look at all of them. Ah, I hate it. I hate it so much. Stop it. Stop it. Is that an A380? It looks like there's an A380 just hanging out back here, and I don't know how to feel about that, seeing one of those in a junkyard already. That's not cool. That is not cool. That's not great. I don't like that. I don't like it at all. There are already A380s that have been phased out. I don't like that. I will say it again. Ooh, an MD-90. I'll say it for a third time. I really don't like that. Can we not? don't even like A380s. Can we not? Ah! Ah! No! Can we not? Like times 3? Can we not? Please? Holy crap. Not cool. Not cool. Please don't do that again. It hurts. It hurts. Times 4. Sure. And also change the subject. There's the just to the east of Mohaver, there's the automotive test tracks. Pretty cool. Former F-14 mechanic PTSD triggered. Yeah, exactly, Octoplex. Yeah, I hear you. All right, guys. Well, that's going to do it for XB-1 coverage. I'm trying to think. We got about 2 hours for Timberborn, so let's pop back over to that or something. According to a few sites, those are all Qantas A380s. Interesting. All right. So I'm going to jog the YouTube video. I'll be back momentarily. We'll switch back over to Timberborn. One more Workers. We'll play Workers tomorrow. All right. Be back in a moment.